everybody, I'm Miss Cooksey, and today we're going to talk about the types of reasoning for geometry and logic statements. So, there's a lot of pieces in geometry that deal with basic reasoning, which is not something we usually get to talk about in our math classes. So, this is actually a really fun lesson because we are going to just use our brains. So, the first type of reasoning we're going to talk about is inductive reasoning. So, inductive reasoning is using a certain number of examples to arrive at a conclusion. So, using examples to arrive at a conclusion. So, for example, the pattern 2, 5, 8, 11, 14, I can use these examples to use inductive reasoning to assume that we are adding 3 each time. The conclusion I would draw there is that the next number would be 17. Go ahead, pause this video, make a conjecture about these patterns, and then check your answer once you're done. So you probably paused the video, you went ahead, you might have noticed that these patterns are minus 15 each time. So the next term would be negative 55. And this pattern is going to be multiplied by 4 each time. So the next number would be 64. The next vocabulary word we need to look at is conjecture. So a conjecture is a concluding statement based on reasoning. Sorry, it's not letting me go over to my answer key. There we go. Concluding statement based on reasoning. So we're going to look at this reasoning and we're going to make a conjecture about the geometric relationship. So if I have angle M and P as a right angle, the conjecture, the concluding statement I can make is that the measure of angle M and P is 90 degrees. If I have angle M, or the measure of angle A plus the measure of angle B is 90, I can conclude that that angle A and angle B are complementary. Go ahead, pause the video, see if you can come up with the rest of the conjectures. Welcome back. Let's go through the answers to the rest. Number 3 would be that points A, B, and C. That AB plus BC is equal to AC. So the length of AB plus the length of BC is equal to the length of the whole thing. A triangle DEF is equilateral. That means angle D is the same as angle E, which is the same as angle F. There's also a couple other choices you could have. You could talk about the side lengths of each of these. For number 3, you could say that all the points are collinear. That's a choice as well. You have options. If angle ABC and CBD form a linear pair, then maybe you say the measure of angle ABC plus the measure of angle CBD equals 180. And if you know that points D, E, and F are non-collinear, then D, E, and F define a plane. So we're using other information that we have to take some information and draw new conclusions about it. The last vocabulary word that we have for today is a counterexample. So a counterexample is a false example that shows that a conjecture is not true. So for each of these, we'll determine if the conjecture is true or false. Notice to go 1, 2, and 4. I chose very specific examples for this. So if angle A and angle B are vertical angles, then their measures are equal. This is true. That's part of the definition of vertical angles. This is always going to be true. When we have angles that are across from each other, They are always congruent. If x is a real number, then 2x is greater than x. Well, what if x equals -2? -4, so 2 times -2 is not bigger than -2, so this is false. This is a counterexample. Last but not least, if two angles are supplementary, then they form a linear pair. Well, what if I have an angle up here that's 100 degrees and an angle down here that's 80? These angles are not connected, they're not adjacent, so they do not form a linear pair. For angles to be supplementary, they do not have to be adjacent. Okay, now we're going to go a little bit more in depth, and we're going to talk about some different kinds of reasoning and different kinds of conditional statements. So the first thing we need to know is that for conditional statements, we need a hypothesis and a conclusion. These are going to be the statements that guide us in our logic. The hypothesis is going to be the statement after if, and the conclusion is going to be the statement after then. So there's a couple different kinds of statements that we can have here. A conditional statement says if P, then Q. So if I have my teaching badge, I'm going to school. A converse statement switches them. So it would say, if I'm going to school, then I have my teaching badge. The inverse adds nots to the conditional statement. So if I don't have my teaching badge, then I'm not going to school. The contrapositive adds nots to the converse. So if I'm not going to school, then I don't have my teaching badge. I think I did that right. I can't remember which order I did the conditional and converse in. We're going to see a bunch of examples of this. What's interesting about all of these different statements is that they change whether they're true or false. So sometimes a converse will be true, sometimes it will not. And we need to use our brains to decide, is that statement going to continue carrying? So if you live in New Jersey, then you live on the East Coast. The converse will be, if you live on the East Coast, then you live in New Jersey. Well, I grew up on the East Coast and I grew up in North Carolina, not New Jersey, so I know that this statement is false. So although the conditional statement is true, the converse is false. The inverse would be, if you don't live in New Jersey, then you don't live on the East Coast. This is also false because I did not live in New Jersey, but I did live on the East Coast. The contrapositive adds nots to the converse. So if you don't live on the East Coast, then you don't live in New Jersey. That's true because if you don't live on the East Coast, it's impossible for you to live in New Jersey. So go ahead, pause the video, see if you can fill out the rest of these examples, and then check back in. Welcome back. Let's go through the rest of these examples. So if a polygon is a rectangle, then it's a square. Is that true or false? So for our converse, we're going to flip these. So if a polygon is a square, then it is a rectangle. That's true. The inverse is going to add nots. So if a polygon is not a rectangle, then it is not a square. That is also true, because in order for it to be a square, it also has to be a rectangle. The contrapositive, if a polygon is not a square, then it's not a rectangle. That's false, because it could look like this and be a rectangle but not a square. If two angles have a sum of 180, then they are supplementary. Well, the converse is if two angles are supplementary, then they have a sum of 180. That is true. The inverse, if two angles do not have a sum of 180, then they are not supplementary. That is also true. And finally, if two angles are not supplementary, then they do not have a sum of 180. That is also true. This would be what's called a biconditional statement, where we can rewrite it using all the different methods and have every single one of them be true. If two angles have a sum of 90, then both angles are acute. Let's look at all the different options here. First option, if both angles are acute, then the two angles have a sum of 90. Well, that's definitely false. We could have a 30-degree angle and a 30-degree angle. Those two angles are acute, but they do not have a sum of 90. Next statement, if two angles do not have a sum of 90, then both angles are acute. That's false again. We could have an 100-degree angle and a 100-degree angle. Those angles do not have a sum of 90, but they are also not acute. Last but not least, if both angles are not acute, if two angles are not acute, then two angles do not have a sum of 90. That is true, because if any of the angles is right or obtuse, they cannot add up to 90. So in this video, we talked about all the different parts of logic statements. We talked about hypotheses and conclusions. We talked about what inductive reasoning is, using examples to arrive at a specific conclusion. We made some conjectures, a concluding statement based on reasoning. Thanks for watching this video. I hope it was helpful. Make sure you subscribe so you never miss a video, and I'll see you next time.